So the purpose of this video is to talk about sex-linked traits. There are certain things in genetics that are determined by your gender. The reason for this that we have to get into first before we can look at these problems, it's because of the chromosomes that make men and women different. When it comes to your 46 chromosomes, remember you get 23 from mom and 23 from dad. The first 22 chromosomes that you get from your parents determine all kinds of traits in your body, but the final chromosome, the only one that doesn't have a number, ends up with a letter. We refer to these as the X and the Y chromosome. Women get two X chromosomes. So they get an X chromosome from their mother and an X chromosome from their father. For guys, you got an X chromosome from your mother and then a Y chromosome from your father. The way we know this is since women are XX, they can only pass on the X chromosome. So for any guys watching this, your X chromosome had to come from your mother, your Y chromosome then has to come from your father. So the interesting thing here is that it's basically guys that determine gender, because women always end up producing eggs that have X chromosomes. It's the sperm cells that have a variety of X and Y chromosomes. The reason this is important is that the X chromosome is actually much bigger. There's a lot more genetic information on it. So basically, girls have more genetic information than guys do. You have more genes, technically. And the reason this is important is there are some traits that are held on the X chromosome. If girls end up getting a bad X chromosome for just one of theirs, but the other X chromosome is normal, that normal one will most oftentimes be dominant and take over. For guys, since you only get one X chromosome, then if you get a recessive trait on that X chromosome, there is nothing on the Y chromosome to take over, so you end up showing that recessive trait. That's why all of these sex-linked traits, they are much more common in men than in women. For example, one of the big ones that's discussed historically is Queen Victoria of England. She was a carrier for what's called hemophilia. So she had one normal X chromosome, but then she had an X chromosome with the characteristics for hemophilia on it. All of her girls were either normal or they were carriers like her, but she passed on this X chromosome to one of her sons. I always forget his name, but the point is he was able to, he didn't live as long because he had hemophilia, which is a clotting disorder. It actually makes your blood not clot as well. Leopold was her son's name. I had to think for a second. But he died around like age 30 because he didn't have, his blood didn't clot correctly. That's the problem with hemophilia. Your platelets don't work the way they should, and if you get a cut or something like that, you bleed much more profusely before it clots up. So something that would be like a routine injury for somebody where, it wouldn't be fun, but you have to go get stitches or something like that, it could be deadly for somebody with hemophilia. But that's going to be more likely in guys because you only get, again, one shot at that X chromosome. So we'll take a look at an example problem for this to give you an idea of how to approach one of these. We'll start the same way we always do, just sort of reading through the problem and figuring out the important information. This is a real disorder, by the way, so this is kind of neat because we get into some of the genetic disorders now at this point in the chapter since we're talking about some of these Mendelian exceptions. But this one is called Lesch-Nyhan syndrome. It's an X-linked recessive condition. This is important. This means if you have a healthy X chromosome, it'll take over, since this is a recessive condition. But it says symptoms of the syndrome include poor motor skills and self-mutilation. In self-mutilation, the individual will bite off the inside of their mouths, tongues, and fingers. I took the picture out of this, but I used to have a handout that had this one on it. We're going to use X capital L to represent a normal functioning person, and X lowercase l to represent a person with Lesch-Nyhan syndrome. Show the Punnett square for a man who has Lesch-Nyhan syndrome and a woman who is a carrier for the disease. So the first thing we have to do is write out the parents. Remember, a lot of these problems all start the same way. Now it says the man has Lesch-Nyhan, so he's going to have an X chromosome with a lowercase l, because remember that lowercase l represents somebody with Lesch-Nyhan syndrome, so we got it right up there. Now remember, his other trait is going to be Y, because guys are always XY. Now, for the woman, it says she's a carrier for the disease. So what that means is she has one healthy X chromosome. So that's X capital L. But then she also has an X chromosome that's carrying the disease for Lesch-Nyhan syndrome. The reason this is important is she will actually be healthy. She would not show the disease, but since she is carrying this X chromosome, there's a chance that she could pass that one on to her kids. And we'll take a look at a Punnett square to see what the predicted values would be for them to pass that on. So we'll get our Punnett square going here. We'll put the first parent along the top. So you've got our guy. Remember, he's X, lowercase l, and Y. And then the woman going down the side, so she is X capital L, then X lowercase l. So if we combine these together in our Punnett square, always write the one with the capital first, because that's the one that's going to take over. So then here we'd have X, L, Y. Now here we've got two little l's, and then X, little l, Y. So if we break this one down, with well, I guess the first thing you would normally do is do the offspring genotypes. They're all going to be unique here. So I'm just going to shrink down my writing tool here a little bit. Then we're going to do offspring phenotype. Like, what would they look like? So for starters, we've got males and then we have females. So we're going to abbreviate this one up here, Lesch-Nyhan syndrome, with just LN to kind of save me some room here. But for males, if we look at our diagram, we've got two males represented here. One of the males would be healthy, right, because the capital L is going to take over. The other male, though, would have Lesch-Nyhan syndrome. So you've got two options, either healthy. Oh boy, that was bad. Hold on. Oh, I can't fix that. Sorry. So we'll try to rewrite that H. Either healthy, or he's going to end up with Lesch-Nyhan syndrome. For the females, if we look at this, we've got two options for them as well. Here's our first female. This one would be healthy because the healthy X chromosome would take over. This one, since it has two recessive X chromosomes, would have Lesch-Nyhan disease, or Lesch-Nyhan syndrome. So again, we've got healthy as one option, and then Lesch-Nyhan for the other. So these people actually have a 25% chance of each outcome. They have a 25% chance of having a healthy boy, 25% chance of having an afflicted boy. They also have a 25% chance of a healthy girl, and a 25% chance of having an afflicted girl. One thing I want you to understand is that the only way that this disease affects women is if the mother is a carrier. If the mother wasn't set up this way, let's say she was different, if she was ending up being, instead of this one, if she was XL, like two capitals, there is no way that her daughters could have this, because remember, the daughters are going to get their X chromosome from their mother, and that's going to take over, or at least one of their X chromosomes from their mother, and then that one's going to take over since it is dominant. So there's a lot to consider with this one. It's interesting because we have two different chromosomes. Because of that, remember, you're going to write the letter sort of in this superscript function up here at the top, which will make things a little bit easier for us as we go through these problems. But also remember, when you're breaking out the phenotype, you sort of have to divide things down into both males and females and then describe their traits over here. So hopefully that was helpful when it comes to the sex-linked traits. There are a few of these in your handout number 2, and then there's one of them in the Punnett Squares packet number 3 for you guys to practice with a little bit in class. As always, thank you for watching, and take a minute to answer the questions at the end of this video.